We have some wires, as you can see, 1 2 3 4 5 6. There are 6 wires in which current is flowing. We will understand when a wire will will be hit, when wire will be hit, when wire will when will wire have a hitting effect. So from this we will try to understand hitting effect of electric current based on threes. First, material. If material wire, if material of wire is what, uh, silver. So if material is big, then wire will hit very soon. Here this material material which is inside wire is what, insulator? No, conductor. So material should be strong. It should be what, copper. Okay. Main point is what, material should be strong. If material is strong, material which is a conductor inside of a wire is strong, then that material wire will not have high heating effect. Instead, they will have normal heating effect. Okay. Here you can see this is a wire which is made of copper. That's why it has what, a normal heating effect. But this is wire which is made of a uh, simple metal. Let's just say it is made of silver. Then it will have heating effect. Because of material which is a conductor is inside of a wire is weak. That's why it will hit very soon, because of material is a material conductor material is a weak. That's why. Based on length. Look, if length of wire is this much, then of course current will flow like that. So it will take time. It will take some time, and it repeats again and again many times, not only times. Each seconds current repeats, mm, which is what, electron comes, then goes, then comes, then goes. So here it take some places inside a wire. That is why that is how long wire comes into heating effect. Long wire comes into heating effect because of electron took some places to produce heating effect. That's why. If length of the wire if length of the wire is small, then it will be impossible to produce a heating effect. Electron will go very soon, very fast, and they electron will not take what place. Yes, we can say uh, a little will be heating effect. A, a length of the wire which is small will have a little heating effect, not high heating effect. No, only little, because electron is going very fast, and they are not taking what some places to produce heating effect inside a wire, because of length of the wire is small. That is how heating effect produce. That is how heating effect produces. Now here, length of this wire is what? It doesn't matter wire is what? Wire is made of a strong material, or it is made of weak material. But if let's just say this is weak material, so then it will hit very soon. But it is made of a strong material, so it will take to hit it will take to hit to produce a heating effect. It will take a time to produce a heating effect, but after sometimes after few seconds it will come into picture of heating effect. Okay, this is what is the difference between strong material and weak material. Okay, now based on thickness, yes, it is a very simple to understand it. How? If thickness, let's say thickness of the marker compared to this pen is what? More. Thickness of this pen is less compared to this marker. So here, let's say this is the thickness of the wire, and this is the thickness of this wire. So it is telling you if thickness of the wire is what? More, then it will have normal heating effect. But thickness of the wire is less, very less, so it will have more heating effect. It will have more heating effect. Okay, so strong material will have a normal heating effect. A small length a small length a small length of the wire will have a normal heating effect. uh, Thickness of the wire is what? More, than that thickness of the wire which is more will have normal heating effect. If material material of the wire is made of big metal, then that wire will have more heating effect. If length of the wire is more, then that wire will have more heating effect. If thickness of the wire is what? Thickness of the wire is very very less, then that wire will have a more heating effect. That is what we had to understand. Now one word more: electric fuse. Electric fuse. It is used in house in many places, so that we can be safe. It is used so that we can be safe. If there is any disorder in electric circuit, then we can help of electric fuse. Electric fuse. If there is any disorder in electric circuit, then we can take this as a help. Okay, help. Now, what is the work of this electric fuse? It will break. It will break a circuit. It will break a circuit of. It will break a closed circuit of electric, and it can complete a open circuit of the electricity. Yes, it is a work of electrical fuse. You would say then what about a switch? Okay, switch also does this work. Okay, but here switch is used to a device, but electric fuse is used for all device and switch is applied for only one device, for example for a fan, for a bulb. So here you see what we switch we uh, click switch to be on, so that bulb can glow. Then we go to the switch and then we click so that bulb can glow. So here we are using a electric switch of bulb, but when we will use this, then this will be for all device, not only one device. And here we will use this electric switch when there is any disorder, when we want that okay we are going anywhere, so here there should not be any here there should not be any current flowing, then we can what use the electric switch. Uh, we use it we switch off this we switch off this electric fuse when we are going to somewhere for few days, for a few months. Then so here it is also important, it is also important in each work. I think in each work it is for our safety. Okay, switch is also for our safety, but there is a user difference between switch and electric fuse. Okay, it is for all device and switch is only for one device. My question is, first statement. This is first statement. You can take it as a question. Fuse wire should have fuse wire. This it is a electric fuse. It is not a fuse wire. In electric fuse is what a fuse wire. So fuse wire should have electric fuse is made of like that. Okay, like that. There will be wire. Okay. So this wire should have what a low melting point. Yeah, it is a truth. It is a truth. This wire which is a fuse wire. Okay, which is a fuse wire. We can name it as a fuse wire. Okay. So it is saying it should have a low melting point so that it can break a circuit. It can break a circuit for all device, and it can complete a open circuit for all device. That's why it should have a low melting point. Okay, that's why it should have low melting point. Yes, it is a truth. Next question, which is the best on electric fuse? This is question with the four options. Now this is complete question. You will answer logically. You will answer logically. Just read this question. You have given four options with the question. It is clearly saying an electrician. There is an electrician. Electrician. We, who is who will be electrician? Who know how to connect, how to create electric circuit in house, in factory, wherever. So electrician is a person who knows about electricity, about creating a circuit, about repairing a circuit of electricity. That person is a known as a electrician. An electrician is carrying out some repairs in your house. Okay, an electrician came into in your house, and you called him because of there is any problem in electric circuit. That's why you called him, and now he will do, that electrician person will do what? Something. He wants you to replace a fuse with a piece of wire. So he will replace a fuse with a piece of wire. So here there is what? Fuse. There is a fuse. There is a fuse. Okay. Electrician will come and will replace what? This wire. This wire. Which of the following wire should he join in the place of a fuse wire? Again, we now, yes, we need to look what options. A small piece of wire having high melting point. Our focus is on this wire. Okay. A small piece of copper wire, a small piece of wire having low melting point, a long piece of aluminum wire. It is what? All these four options are telling what will be what will be made, what will be made of wire. Okay, so of course wire should have what? Wire, fuse wire especially should wire uh, especially fuse wire should have what? Low melting point in the case of electric fuse. Okay, so when it comes to fuse wire, then fuse wire should have low melting point instead of having high melting point, instead of having copper wire, instead of aluminum wire. So this third is the correct answer. It is a truth. It is a fact. What? Fuse wire has what fuse wire has low melting point. It is a universal truth, and that is what you have to remember. Otherwise you can say it is the universal truth. We cannot say that it is incorrect. So here, of course, this was our answer. Now next question, which is very interesting with a figure. Diagram is like this. This is a figure from this question. From this question, we have four options. First is this is what we have complete question with the four options. We have to answer which one option is a correct for this question. By understanding this question, we will be able to answer, and also by understanding this figure. Now it is a figure. This is what? This is a battery, which is a collection of more cells. This one cell, this is second cell, this is a third cell. There are three cells, which is forming a battery. That's why we can say it is a battery instead of saying cell, because of there is a more collection of cells. Now this is one we have understood what symbols of making our electricity. This is a symbol of electrical. This is also symbol of electrical. This is also a symbol of electrical. Now you are crystal clear that there are three bulbs, and it is a what? It is a symbol of a switch, and it is a switch off. It is a switch off because of this is open. If this was closed, then we call it as a what? Switch on. But now this is a in position of off. Okay, that's why this switch is off. It is a symbol of a battery. We have four, and this is wire. This is a symbol of a wire. This wire, this wire. Okay. Now we can say one symbol, second symbol, third symbol, fourth symbol. We have four symbols to make it as an electric circuit. Yes, of course it is an electric circuit. Question is the same in this circuit, which is shown below. What will be the order in which the bulb A, B, and 3, all these three bulb will glow when this switch will move to the on position? But it is a current. What it is? What current? It is what switch off. But when it will be moved on, when it will be moved, it will be moved to the on position, then which one bulb will glow faster, will glow first? Okay, this is what question is saying. So which one bulb will glow firstly? Here option which is given, first bulb A will glow, then second bulb B will glow, then third bulb C will glow. Second option is saying it is not a correct answer. I am just reading. First of all, this bulb C will glow, then bulb B will glow, then bulb A will glow. This is what option number second. Option B is the same. Third option is the same. Bulb B will glow firstly, then at the second time bulb C will glow, then bulb A will glow. D, fourth option is the same. All, including A, B, C, all these bulbs will glow at the same time. Now, as we know, electrons comes like this. Okay, electron comes and goes like this. Electron works like that direction, in that direction. Proton will go from here like that, then it will end here, then it will come out from this one, then like that. That is how electron works. Now here we are talking about electricity, we are talking about current. We are not talking about a car, a bike. We are not talking about a human. Here current. When word is a current, so it travels. Current travels very fast, even we cannot imagine. Yes, it is true. Even you can imagine. Current travels very fast. So we cannot say that first of all this bulb will glow, then this bulb will glow, then this bulb will glow. First of all this bulb will glow. No. Current will travel that much faster. This all bulb will glow at the same time because of current is traveling very fast from here to till here. When will it arrive here, we will not be able to imagine. Yes, in 1 second, you can say within a 1 second, from here to till here, current will come very fast. Yes, it is an motion within a 1 second. Okay, so yes, all these three bulbs will glow at the same time. Option D is the correct option. It doesn't matter there are two bulbs, there are three bulbs, there are 100 bulbs, there are 40 bulbs. It doesn't matter. It doesn't matter. Okay, at the same time all 40, 100 bulbs will glow at the same time. This is universal truth. Behind it is a reason. What? Electron travels very fast, which is present inside of wire. Electron which is present inside of wire travels very fast. That's why all bulbs that are present in electric circuit will glow at the same time. Okay, we don't care about the numbers of bulbs. No. Okay, all numbers of bulb will glow at the same time. It is a universal truth, and behind it is a reason, which is what? Electron travels very fast. That's why all bulbs which are present in electric circuit will glow at the same time. That is what is the reason. So finally, this is answer for this equation. We have answered this by understanding this application. Now next concept, magnetic effect. I think next concept will be magnetic effect. It is said that if magnetic material behaves like a like electricity, Yes, uh, magnetic attracts conductors. Magnetic attracts a magnetic material like a electricity. Electricity attracts something. For example, we are here and there is a net wire where current is flowing. So when we will touch, then we will be attracted by that net wire, and there is a process that is so this process is behaving like a magnet. Magnet also attracts magnetic material, but we are not magnetic material. Here we are saying that if there is an insulator, if there is a magnet in electric circuit, so magnet will behave like a conductor, Okay, we will have magnetic material in electric circuit, and this is what is the next concept that we are going to explore. we have this figure. Option no, yes. Here, this is what magnet is. This is magnet. This is magnet. Here, this is wire, which is what enclosed, which is enclosed with wire. This is wire which is enclosed with the magnet. Now, here, will the campus needle this show show deflection when the switch is closed in the given circuit. So when it will be closed like that, then will this compass needle will show deflection? Yes, it will behave as a current when switch will be moved to the on position. Then answer would be yes. Next question. Next question. This is a figure. This is figure, but question is something else. Question is something else. When this switch is from this question, we understood that this will behave as a current. This is what we understood. Next, we will understand heating effect, magnetic effect with equation. This is what is the last question. This is question with the 4 option. This is competition. Here in the circuit given, this is what we have given. In the circuit given below, which is below, when the switch is closed, this is a switch which is in position of off. When it is closed, what will happen? This is what we have to answer. But before, read this. Okay. Which of the following effects of electric current can be observed around the thin wire after some time? This is wire. Okay. What will be effect? Whether it is a heating effect or magnetic effect. That is what we have to take. And effect of this wire, we have to answer. What is the effect of this wire? So how to answer? How to identify? So here, look. This wire will behave as a magnetic effect, of course, because it is enclosed with a magnet. This wire is enclosed with a magnet. Okay. Now we have this wire. So of course this wire, after some times, yes, that is the truth. After some times, this wire will have heating effect. Of course, it will have heating effect. But this wire is what? Let's say this wire is length of this wire is small. Then it will take a long time to have heating effect. But it is a long wire. So of course, after some times, it will produce heating effect because of length of this wire is more. That's why. Now this wire is enclosed with magnet. That's why here this magnet is working as a current. Otherwise, you can say yes, it is working as a current, but it behaves as a current. Okay. So here, of course, first of all, this wire will produce heating effect after some times. So there would be heating effect, and second, there is what? Magnet. There is a magnet. So of course, there is a magnet. It will act as a magnetic effect. It will act as a magnetic effect. So we have two effects. First, heating effect. Second, magnetic effect. So not only heating effect, not only magnetic effect, neither magnetic effect, heating effect, it is incorrect. This is also used also. In this circuit, we have two effects. First, magnetic, second, heating effect. So C would be answered for this equation. That is how you will answer logically. Okay, not unnecessary, not blindly. Here this wire, of course, after sometimes it will produce heating effect. Here this enclosed wire is working as a magnetic effect, and this magnet is behaving like the current, like the electricity. Next question. have this partition in which we will fill. So here the longer line in the symbol for a cell represent. It's what? So I think it would be longer line. So longer line is a positive terminal for a cell represent. The combination. What is the same? The first. Okay. This is a positive terminal and this is a negative terminal. Positive terminal is made of metal cap and negative terminal is made of disc cap, metal disc. Okay. Here this is sign we will understand from this symbol. This is a longer line and this is a thin but short line. Okay, short line. So this is a positive terminal which is a longer line. That's why we have paired here this word positive terminal. The combination of the two or more cells will be considered as a diagram. Yes. But single cell will not form a diagram. Okay. There should be two or more cells. When current is switched on in a room heater, then what will happen? It will get more heater heats. This safety device based on the heating effect of electric current is called electric fuse. So the safety device based on heating effect of the electric current is what? Electric fuse. So here this will be fuse. This will be fuse. Next we have question. this is what we have for question in which we will have to tell which one is a false, which one is true. Here to make a battery of two cells, yes, it will be possible to make a battery from two cells, yes. The negative terminal of one cell is connected to the negative terminal of the another cell, so it will not form a battery. It will not form a battery because a cell, a terminal of the cell is connected, which is a negative terminal, and negative terminal of a cell is connected to the another terminal which is also negative terminal with the other cell. So that's why it will not form battery. Here connected terminals with two cells should be opposite, plus negative, positive negative, negative positive, not negative negative, not positive positive. Instead positive negative, negative positive. Then any two combination of the two cells will form a battery. Okay, so that's why it is incorrect. Now, when the electric current through the fuse exists a certain limit, the fuse wire melts and breaks. Yes. The fuse wire melts and breaks. Yes, it is true. And this is work of a fuse wire. Fuse wire will melt and break when there is when the electric current through the fuse exceeds a certain limit. Again. And electromagnet does not attract a piece of iron. Iron is a conductor. Now here what is the electro, and second what is a magnet. Suppose magnet does attract any iron, electron will also conduct iron to produce electricity. So of course it is incorrect. Work of electromagnet attracts magnetic material and conductors. Okay, and electric bell has a electromagnet. Yes. What is the magnet? So of course, so here what is electric? So of course this bell will have electromagnet. That is true. That's all from this slide.